The next problem I'm going to do is number 10 here. Right? A conical paper cup is 20 centimeters tall with a radius of 10. And the bottom of the cup is punctures, the water leaks out. Okay, so we have a conical paper cup. Okay, and we know that at the beginning this whole thing is 20 centimeters tall and the radius is 10. Okay, water is leaking out. I'm going to grab a second color here for my water. Water is leaking out the bottom there. All right, for me. Okay. And so here's the water level within it. Okay. Remember that since the water is leaking out, this water level is changing. So the radius of the water and the height of the water are always changing throughout this problem, which means you can't plug in any radius or height values until after you've taken that derivative. Okay, so let's think about the water, sticking with the color blue here because blue is representing my water for this one. All right. Okay. So we can see that this is 16 pi over 3. And it's leaking out, so I'm going to make it a negative. We're losing it. And at what rate is the water level changing? So that's the water level, so that's the depth of it changing. When the water level is 8 centimeters, so we have that. Okay, so oops, that's a dV dt. I put that under V, but that's dV dt there. Okay, we don't know how quickly the radius is changing, right? But really it doesn't matter because we're trying to find how quickly the height's changing. Our formula to relate all these: 1/3 pi r squared h. Okay. If I took the derivative here, I'd need product rule and I'd have dr dt in it, and I don't really want any radii in it because the radius is, I don't have any information about it, so I really just want to stick with the h's. So that tells me why I'm going to replace the r, because there's only, I need to find dh dt, I don't have any information about dr dt, so that's why r needs to go. Okay, so here are my similar triangles for myself. The water creates one triangle right here. Okay, and the cone, the actual way the cone's set up, creates another triangle right here. So there's two triangles being both right triangles, and they're sharing this angle, so they're similar by angle. Right? The cones for the side lengths for the cone are 10 and 20. Okay, whoops, sorry. So the 10 to 20. And those are proportional to, 10 is proportional to r, and 20 is proportional to h. Okay. If I reduce that fraction, then I can and then cross multiply. I see that h equals 2r. Okay. Or really, I need to solve for r. We said, right? So r equals h over 2. So that's going to be plugged in right here. Once I square that, I'm going to get h cubed over 4, right? H squared times h for the h cubed. Okay. I mean, I could put these two together. It's not crucial. I'm going to take the derivative now. So it's going to be 1/3 pi. The derivative of this is going to be 3h squared over 4 dh dt. All right, that 3 is going to cancel that. You should expect that to happen in every cone problem. You're going to have those 3's cancel. So let's see, we know what dV dt is. We have the pi over 4. We have the h squared, right? 8 squared. And then we're trying to find dh dt. Okay, you can see that because we got rid of the r's, we had all the information we needed in that derivative there. Okay, well, that's going to reduce. I'm going to divide both sides by 16 and by pi. Divide by 16, divide by pi. Okay, I get this. So I can see at what rate is the water level changing. Okay, so the water level is decreasing at 1/3 pi centimeters per second. Okay, and that's how we get that answer right there.